In previous video we discussed about introduction of solids, that is types of solids, types of crystalline solids, crystal lattice or space lattice, unit cells, lattice points, and the position of lattice points in unit cells. There are some more points regarding unit cell. We will discuss those points in this video. Here you have to know one more point regarding unit cell. Just now we discussed position of lattice points in unit cell. How many positions? 4 positions. They are corners, edges, faces, and body center. Body center, face center, edges, edge center, and corners. 4 positions are present in any unit cell. That is the point. That is the main point. Now here one more point is there regarding this one. That is, here one table is there: position of lattice point, number of lattice points, sharing of lattice points, and contribution of lattice point for one unit cell. This is also very important. This is one of the important topic in this chapter. See, this is body center, this is face center, this is edges, corners. We discussed already about them. We discussed already number of lattice points also. Body center only one is present, face center 6 face centers are present, edges 12 edges are present, corners 8 corners are present. Yeah, these two columns are somehow difficult. You have to imagine carefully. See, sharing of lattice points. Suppose 2 members are working for 100 rupees. Then each one get how much? 50 rupees. That is how 100 by 2. That is called contribution. Those 2 members are sharing. Total contribution is 100 by 2. That means 50. Suppose 3 members are working for 100 rupees. So here sharing is 3. 3 members sharing. Its contribution is how much? 100 by 3. Almost 33.33. And one more example. Suppose 4 members are working for 100 rupees. Then its sharing is 4. And its contribution is 100 by 4. That means almost each one gets 25 rupees. Like that, here also we have to discuss some points regarding this one. See, this is one unit cell. This is also one more unit cell. Let us assume like that. Suppose my point is, if the particle is present inner side, that means body center. If that particle is present, if that unit cell is present, I told you already that the crystal contains so many unit cells. Suppose if the particle which is present body center of one unit cell cannot share the particle to other unit cell, because that is present in body center. So that unit cell only shares that particle, so that its sharing is only 1. And its contribution is also 1, because that is present in body center. So that body center particle cannot share, that body center lattice point cannot share other unit cell, so that its sharing is 1 and its contribution is also 1. Next one, face centers. I discussed already. How many face centers? 6. I will tell once again. 1, 2, 3, 4, 5, 6. 6 lattice points are present. 6 face centers are present in any unit cell, not crystal, in any unit cell. The point is sharing of lattice points regarding face center. Suppose if a lattice point is present at face center, then its contribution is how much? See, this is one unit cell, this is also one more unit cell. Suppose if these 2 unit cells are present like this in crystal, all unit cells are close to each other. So automatically the particle which is present at face center shares other unit cell. You can understand like this. Suppose if a particle is present at this face center, automatically that face center lattice point shares other unit cell. So its sharing is how much? 2. Then its contribution is how much? 1 by 2. Its contribution is how much? 1 by 2. Because one particle is present. So 2 unit cells are sharing. So that its contribution is how much? 1 by 2. Next one. Edges. I told you already, edges. between two corners, that is called edge. This 1 2 3 4, backside also 4, 8 9 10 11 12. These are 12 edges. This is somehow difficult to imagine. If a particle is present at edge center, that means here or here or here, suppose if a particle is present at edge center in one unit cell, that particle shares 4 other unit cells. Because see, this is one unit cell, this is one unit cell. Let us assume the particle is present here. So if these two unit cells are present at the side, then these two are shares that point. If we keep one more unit cell here and one more unit cell here, those two unit cells also shares that lattice points. So the sharing of lattice points is how many? 4 in case of edge centers. Then its contribution is how much? 1 by 4. You should imagine this point. Next one, corners. Corners is how many? 1 2 3 4 5 6 7 8. Back 4, front side 4, back side 4. Total 8 corners are present in any unit cell. It's a sharing of lattice points. Here sharing is also 8, because if all unit cells are present here, then each corner share by 8 unit cell. Each corner shares by 8 unit cell. Suppose if these two are present here, then this corner shares this unit cell. If you put one here and here, then total 4. Above 4, then each corner shares 8 unit cells. That is 8, and its contribution is 1 by 8. So this is very important point. So the contribution of body center is 1, the contribution of face center is 1 by 2. This is very important column. You have to remember this column. And the contribution of its centers is 1 by 4, and the contribution of corners is 1 by 8. Next one, unit cells are two types. They are primitive unit cells, that is also called simple unit cells, and one more type, non-primitive unit cells. I repeat once again, unit cells are two types: primitive unit cells, that is also called simple unit cell, and second type, non-primitive unit cells. So primitive unit cells means the unit cell in which lattice points are present only at corners. I repeat once again, the unit cell in which the lattice points only present at corners, that is called primitive unit cell. In corners, total number of lattice points 8. So its contribution is how much? 8 into 1 by 8. 8 into 1 by 8. Each corner contribution 1 by 8. Total corners 8. 8 into 1 by 8. That means 1. That means if the particles are present at corners in unit cell, then the total number of atoms in that unit cell is 1. Then the total number of atoms in that unit cell is 1. Next one, non-primitive unit cell. Primitive unit cell definition means the particles which are present only at corners, that is called primitive. Non-primitive means the unit cell in which lattice points are present at remaining portions in addition to corners. Remaining portion is body centers, face centers, corners. The particles which are present at lattice points, the particles which are in which the lattice points are present at remaining portions in addition to corners, that is called non-primitive unit cell. It is again classified into 3 types. They are body centered cubic unit cell, face centered cubic unit cell, and end centered cubic unit cell. Body centered cubic unit cell, face centered cubic unit cell, and centered cubic unit cell. Simply BCC, FCC, ECC. ECC means end centered cubic unit cell. Now we will discuss about these 3. Body centered means, in name itself, body centered. That means the particles which are present at corners along with body center, that is called body center. So the definition is what? The unit cell in which the lattice points are present at body centers in addition to corners. is called body centered cubic unit cell. Here number of lattice points, how many? 9. 8 corners plus 1 body center, that is 9. See, this is structure of body centered. 1 2 3 4 5 6 7. 1 2 3 4 5 6 7 8. 8 corners, this is body center. Total number of lattice points 9. Next, face centered cubic unit cell. In name itself, face centered, that means along with corners, particles should be present at faces. So the definition is what? The unit cell in which the lattice points are present in faces in addition to corners, that is called face centers. So total number of lattice points, how many? 14. 8 plus 6, 8 corners plus 6 faces. Total number of lattice points 14. And next, last one, end-centered cubic unit cell. Here the definition is somehow different. See, the unit cell in which the lattice points are present at any two opposite faces. We should take any two opposite faces, not all faces, in addition to corners. Total corners, how many? 8. Plus any two opposite faces. Suppose if you consider this face, we should consider this face only. These two are opposite faces. Suppose if you consider this face, we should consider this only. If you consider this face, we should consider this one. So we should consider any two faces. Those two faces should be in opposite. So the definition is what? The unit cell in which the lattice points are present at any two opposite faces in addition to corners is called end-centered cubic unit cell. Here the number of lattice points, how many? 10. 8 corners plus any two faces plus 2, 10. Regarding this one also, one table is there, that is also important. See, types of unit cells. Simple cubic unit cell, that is also called primitive unit cell. Next one, body centered cubic unit cell. Next one, face centered, and last one, end centered. What is the primitive unit cell? Only particles are present at corners. So 8 particles, corners means 8. Then how many number of units sharing lattice points? 8 unit cells. I discussed already. 8 unit cell shares. Then its contribution 1 by 8. So total number of atoms belongs to one unit cell, how many? 8 into 1 by 8. Just now I discussed already about this one. 8 into 1 by 8. That is equal to 1. That means if particles are present at only corners in any unit cell, then the number of atoms in that one unit cell is equal to how much? 1. That is the meaning, because 8 corners are present, that means 8 lattice points are present, but those are shared by other unit cells, so that the profit is how much? 1. That means 1 atom is present. BCC, body centered cubic unit cell. So what is the definition? 9 lattice points, that means 8 corners plus 1 body center. 8 plus 1, 9. Its sharing is corners 8 unit cell, body center 1 unit cell. I discussed already about this one. So here contribution is 1 by 8. For this contribution is 1. So total 8 into 1 by 8 plus 1 into 1. 8 into 1 by 8 means corners. 1 into 1 means body center. That's sharing also 1. 1 into 1, total 2. That means if particles are present at corners and body center in any unit cell, then the number of atoms is equal to 2. That means profit is 2, because after sharing and contribution, the profit is how much? Only 2. You should think like that. FCC, face centered cubic unit cell. FCC means 8 corners, 6 faces, total 14. 8 corners shared by 8 unit cells, and 6 faces, each face shared by 2 unit cells. So its contribution 1 by 8, its contribution 1 by 2, total 8 into 1 by 8, and plus 6 into each face contribute by 1 by 2. That is 4. That means if particles present at corners and faces, then total number of atoms belongs to that unit cell is equal to how much? 4. Next, end-centered. End-centered means ECC means end-centered cubic unit cell. That means 10 lattice points. That means 8 corners and any 2 faces. For 8 corners, contribution 1 by 8. 2 faces, contribution 1 by 2. 8 into 1 by 8 plus 2 into 1 by 2, total 2. So what is the important point here? If in question if simple cubic unit cell is present or primitive unit cell is present, then how many number of atoms belongs to that unit cell? 1. In question BCC is present, how many number of atoms? 2. In question FCC is present, how many number of atoms? 4. In question ECC is present. That means we face some numericals regarding this one. If BCC is mentioned in that problem, then how many number of atoms? 2 atoms. If FCC is mentioned in the problem, how many number of atoms? 4. If ECC is present, how many? 2. If simple cube is present, how many? 1. So this is all about unit cells and space lattice. This is somehow difficult topic. You should imagine it, then only you can understand. If you have any doubts, we will discuss those doubts in live class. Thank you.